So, a couple of reminders off of yesterday's notes. First one, biggest one. When we're transforming these, we can only touch one side of the equation. Whichever side you choose to work with, that's the only side you work with. So most of the time we deal with the more complex side because what can you really do with negative cosines theta or whatever it happens to be? So work on the more complicated side. Use our basic identities, these guys, to help simplify things. And again, operations, fractional, distribute, factor, whatever it happens to be, to kind of get you to that. And again, sines and cosines, very friendly. Not a bad idea. Okay? More times than not, if you change something that's not a sine or cosine into that, things will start to clear up a lot quicker. We can multiply numerator and denominator by the same trig expression if that would happen to help. And again, keep peeking over as you clean things up to see, because sometimes that'll give you a clue on what's coming next. And then if you have to, have an eraser ready, because you may have to start over. It happens sometimes. So we did talk about these first two yesterday. Worked our way through, turned things that weren't sine and cosine into that, and simplified, and we worked our way through those pretty well. So now we're going to continue to do that. So again, I'm going to take the side that looks less complicated. I'm not sure on 2 yet. We'll see which way we want to go when we get there. And start working these. Now again, I want to stress throughout all of this, one thing you do have to follow that you don't have a choice on is order of operations. So on the left side here, you don't have a choice. You can't use 1 plus cosecant squared first, even if you wanted to, because order of our operations tells us multiply comes before add. So, with that in mind, cosecant squared, let's see if I can get all of this in again, can be worked a couple of ways. Now, since in here I don't see plus minus stuff going on, I tend to swing more towards this because remember, one of my things that I can do would be square both sides of my equation. So cosecant squared could be 1 over sine squared. Cosine will let stay as itself. So I'm like, okay, so probably don't need this again for a little bit. Get that together as one fraction, which is cosine squared over sine squared. And then hopefully things might start to become a little more clear. Because I look at cosine squared over sine squared, and I notice, hey, cotangent's cosine over sine, and we just got done saying I can square both sides of one of the identities. So this is going to become cotangent squared. And you're like, but wait a minute, there's nothing else I can really do. Well, that's because there's nothing else you really need to do. Because 1 plus cotangent squared equals cosecant squared, and I'm done. That's what we mean when we say keeping an eye on what's going on the right, because a lot of times you'll be able to start looking at your identities and figure out, ooh, that's where I'm heading towards with this, and it might help you make that extra step somewhere. Now, to me, I know we kept using the right side every time with these. I would consider boxing this off, maybe this time, and using the right side. Both can work. But normally when you see a plus or minus, that's going to be a little more complex to work with, and it might clean things up a little better. So that's the route I'm going to go this time. If you want to try the other way and see if we end up in the same place at the end, I'm all good with it. All right, cotangent. What should we turn cotangent into? Okay. cosine over sine. So we've got cosine over sine. And then what about tangent? Sine over cosine. Now, we are not fortunate enough that we can just go cancel crazy here because, again, this isn't times, it's plus. I'm going to need a common denominator. So, my common denominator means I'm going to need both of my trig functions in the denominator. So here comes the question, and it might be one where I want to do a little bit of side work. Because I might say, okay, so I'm starting with cosine over sine, and I want to get to cosine sine. What do I have to multiply the first denominator to get to the second? Cosine, because I've already got the sine part. But whatever I do to the denominator, I also have to do to the numerator. Okay, so I'm building a fraction, basically. Cosine times cosine is cosine squared. So that would be my first term. And if some of you are used to seeing patterns and working with them, you'll see one here quickly. Because my second fraction, my original, was just the opposite, sine over cosine. And again, I'm trying to get to that new denominator. To get there this time, I already have the cosine part. I need another sine. So I end up with sine squared as my second term. So anytime you see cosine over sine plus sine over cosine, that's what it'll end up being each time. You're like, okay, I don't know how incredibly helpful this is so far, but at least we got that together. So now I start peeking around. Now I go, okay, does cosine squared plus sine squared get me anywhere? It sure does. Sine squared plus cosine squared is 1. So I have 1 over sine theta cosine theta. And some of you may be in a panic at this point. You're like, wait a minute, we're at one fraction. That's two separate things. What are you doing? Well, remember, if you're multiplying by something, you also can take the individual pieces of it and break it apart. Because if you think about it, if I were to multiply these two together, 1 times 1 is 1, sine times cosine is cosine, so it's not like I'm doing anything that algebraically is illegal. And then all of a sudden it becomes clear. Hey, 1 over sine is cosecant. 1 over cosine is secant. Woohoo! And again, with just about any of these, you could try to use either side, but again, it's more, the more complex it is, the easier it's going to be to break down and have different things to be able to do. That's going to be your key on these. It's just kind of playing those out. Any issues with that one before we go flipping over and playing a bit more? I'm going to throw a couple of simple ones at you, and then we're going to get into a big one. You're like, I don't know, this is kind of strange. All right. So let's flip over. We'll get to a couple of easier ones here, and then we'll ramp it back up. 1 minus sine squared. On your identity sheet with all your switching around here, does that equal anything? Okay, cosine squared. 1 minus sine squared is cosine squared. And again, if you've got that identities sheet and you haven't done some of the switching around on there yet, I would. It's going to be a really helpful sheet to you as you start to do this. You're like, dang, this one's going to go really quick because now it's cosine over sine which is just cosine. I'm done already. So they don't all have to take like 6 steps. Sometimes, but not always. But I will always choose the plus or minus side over the other when I'm trying to do my verifying. All right, left side. What's tangent going to turn into? Sine over cosine. We just got done with 1 minus sign a minute ago here, saying it was cosine squared. So I go, okay, let's see. Cosine there. Oh, sine theta. And this cosine will go away and get that squared rid of. Well, that was good. Okay. That took care of itself pretty quick. But again, that unfortunately isn't going to happen every time. 5 might bring me a nightmare for a minute, but I'm well prepared for it this time. I've got this ready to go. There is the infamous 1 plus and 1 minus a trig function sitting in the denominator. No worries. It's going to be like the one we did yesterday that got a little lengthy. So save yourself some room here. So I start to look and I say, okay, basically here, to get this into a set where I've got my correct denominator, which is going to be 1 plus the sine of t, 1 minus the sine of t. And I'm actually going to break this into the 2 this time. Because I want to see how every piece of this works. The first fraction, I've already got my cosine, and I also do in the second. But I want us to be able to visually see where this building of the fraction comes from. So I'm like, okay, got my common denominator, got what's already up here. To get from here to here, I already have the 1 plus. I need the 1 minus sine t. And then just the opposite in my second fraction. I've already got the 1 minus. I'm going to get the 1 plus. You're like, ew. So I'm really going to have to distribute all of this out. For the time being, yes, but you'll be pleasantly surprised at how simplified this gets. My denominator, okay, if I FOIL that out, which is what I'm also going to do here. So let's see. So I'd have 1 minus the sine of t plus the sine of t minus sine squared t. That's just foiling out my denominator. Didn't have to do anything too fancy there. And then my numerator, when I distribute that through, oops, not cost, cosine of t, minus cosine of t, sine of t, and then we'll do the same thing over here. Plus cosine of t plus cosine of t, sine of t. Okay, all these t's and cosines and sines. I've got to take a minute here and look at all this stuff. All right, let's see. Plus and minus cosine t, sine t. Okay, so those guys cancel. So I have 2 cosine t, because I'm adding them and not multiplying them, so it's not cosine squared. My denominator, my plus and minus sine t cancel. Leave me with 1 minus sine squared. Finally making some progress here. We've gotten from 2 fractions down to 1, which is good because I see that's going to be necessary here. What can I do next? In in the denominator. What's 1 minus sine squared? Cosine squared. So 2 cosine of t over cosine squared of t. Oh, I'm getting close here. I'm going to squeeze in here. Cosine squared, there goes my cosine, 2 over the cosine of t. Now this one may not be obvious. You're starting to look at the answer and you're going, okay, watch our shenanigans here. Two times 1 is 2, but it's 1 over the cosine of t. And if I look on my handy-dandy trig identities, I see, oh, 1 over cosine is secant. How convenient. Ew. Hope they're not all that way, but they're not. They're not. It's just like everything else of these. It's just getting used to. It's like the factoring and all that other good stuff. All right, we're going to take a peek at 6 and 7. Then I'll give you a little time to play here. You're like, wait a minute. First of all, I don't see any fourths on my identity sheet. No worries. Here's the way I want you to look at this. Think of it as though it was x to the 4th plus 2x squared plus 1. That's factorable. If I were to factor that, what would that look like? Let me back up one more step. We'll build up to it. What if it was just x squared plus 2x plus 1? What would the factored form be? Okay, x plus 1, x plus 1. So the only difference now is, since we've gone from squared to the 4th, our x's are going to take on squareds. So you're like, okay, we're building back up to this mystery thing. So now the same thing happens here. Tangent squared plus 1. Tangent squared plus 1. I've seen that somewhere before. 1 plus tangent squared is secant squared. So secant squared times secant squared is like x squared times x squared. Which is x to the 4th, or in this case, secant to the 4th. And I'm done. So, I mean, we get to pull all the tools out. Factoring stuff, distributing, switching signs, adding, subtracting. You're like, holy cow, man. All right, oh.
The interruption is Jenna Corey in class
7. This way we can spread out a little bit. All right, there's what we're shooting for. You're like, everything is sine and cosine already. That's true. So we're going to go a fraction building. My fraction consists of both of my current denominators. Not always pretty when this happens, but it's just one of those things we have to deal with. So I've got my new denominator set, 1 plus cosine x times sine of x. And now again, I just kind of look and say, okay, already got the 1 plus cosine part. Need another sine of x. Already got the sine of x part. Need another 1 plus cosine of x. That is some pure ugliness. So I look and I go, okay, so sine squared of x. And then I'm going to FOIL this out. So I have 1 plus a cosine of x plus another cosine of x. So 2 of them. Again, not cosine squared because I'm adding, not multiplying. And cosine times cosine is cosine squared of x. And I'm saving my coolest trick for the end. When I get to here, I can rearrange the terms because, again, when you're adding numbers, it doesn't matter if you're adding 4 plus 7 or 7 plus 4. I can rearrange them. Why would I want to do that? Because I can get sine squared plus cosine squared that way. Ooh. Which equals 1. So my next step becomes, okay, so if this is all 1, 1 plus 1 would be 2 plus 2 times the cosine of x, and believe it or not, we're getting close. You're like, blast it, these are close to being the same. Wait a minute. Those two terms have anything in common? 2. If I take the 2 out, now all of a sudden, all I see are parentheses and multiplication everywhere, which now means I can cancel those out. And we're going to use the same trick we used in the last one. I have 2 over the sine of x, but we said before I can pull that 2 out front, and 1 over sine of x is cosecant. It's like doing detective work with a really sneaky crook that you're dealing with. But at least, like I said, you know what you're trying to get on the right side. So again, the challenge now is to work on the worksheet that you got yesterday with this. And then that book work is kind of a separate assignment because I didn't want to pile that much on at once. So work on part, then maybe work on a different part of it Tuesday, and then when we see you on Friday, we can see how this is going a little bit better. But if you get stuck, I will be after on Tuesday. I'm just not going to be in class.